Imagine a single server trying to handle thousands of users at once. It would crash instantly. That is why we need a load balancer to act as the traffic cop. Without load balancing, every client request goes directly to one server instance. This creates a bottleneck where the system relies on a single point of failure. By inserting a load balancer between users and three servers, we distribute incoming network traffic. Now, no single server bears too much of the processing load. Static algorithms like round robin simply cycle through servers sequentially. However, modern systems rarely operate under perfectly balanced conditions due to varying request complexity. Dynamic load balancing adjusts in real time as infrastructure changes through auto-scaling. Different requests require different amounts of processing power at any given moment. This continuous distribution ensures your applications remain fast and reliable. It prevents downtime by ensuring the system does not rely on just one server instance. Ultimately, load balancing allows you to scale horizontally. Instead of upgrading one massive machine, you simply add more servers to handle the growing user demand. So, load balancing turns a fragile single server into a robust cluster. What other infrastructure concepts should we break down next? Let me know in the comments.